Chemistry Minions, video 4. Let's get into these half reactions. Now that we can assign oxidation numbers, now we can start. We'll assign oxidation numbers, and then we, from there, can determine now who is gaining and who is losing electrons, and I can write the actual half reactions that show who is losing and who is gaining. So let's get into it. And then the agents, the opposite. The agent's always going to be the opposite thing. You'll find that out when we're done with this. So quick, all the theory, we'll get into some actual examples that look like what is in your practice packet. So I'm going to do this verbally, so you need to be listening. I can start by putting a 0 on top of the Ca and a 0 on top of the Mg because lone elements get a 0. Mg only has one choice on a periodic table, +2. Yep, I looked right up and still looked at it, right? Ca, +2. Br, one negative choice, -1. Okay, I can assign the oxidation numbers. Notice Br is a -1 on the reactant side. It's a -1 on the product side. He's not changing, so we call him a spectator ion. He's not in charge of any electrons. His oxidation number isn't changing. The Mg in the compound, again, is a +2. Then it's going to an Mg with a 0. So there you go. Mg and Ca are the metals that are swapping, obviously. It also doesn't matter if I could have wrote the reactants as Ca plus MgBr. I think a lot of the times we get the lone metals first, like it is on the product side. Again, it doesn't matter. We can still assign oxidation numbers. Once we assign the oxidation numbers, we can obviously see who is changing and who isn't. That change is important. Okay, so Mg going to Mg, I verbally just told you it's going to be Mg with a +2, going to Mg with a 0. That is not quite complete because it doesn't have its electrons, so we'll get into the half reactions in step 3. Ca is going from a Ca0 to a Ca +2. That's what I verbally just did when we assigned the oxidation numbers. I didn't put those numbers up, though, for you. Remember, I just did it off the dome. In class, I'll put them up for you, and you'll see it a little bit more clearly. Spectator ion, in this case, is Br. He's a -1 on both sides. He's not gaining or losing electrons. He's just along for the ride. He is spectating. So now I got to figure out, where am I going to put these 2 electrons? So first of all, it's going from a +2 to a 0. It should go without question that it's 2 electrons involved. It can't be 1. Okay, it's got to be 2 now to go from a +2 to a 0. Now, what makes sense? Mg +2 gaining 2 electrons or Mg0 gaining 2 electrons, right? Well, Mg +2 means my protons are winning by 2. Why? Because I lost those electrons. Hence, I must gain electrons to get back to 0. So gaining is on the reactant side, so I'm going to write it like that. Now I know oil rig reduction is gaining. Mg +2 this is the reduction half reaction. See? Mg +2 is gaining 2 electrons to become Mg0. Okay, let's do it. Let's do the full paces. If we have one, we can write the other. Which one makes sense? Ca0 plus 2 electrons. We'll check it. If I added 2 electrons to a Ca0, I would be as Ca minus 2 because 2 electrons have a negative charge. And it's not Ca with a -2, it's Ca with a +2. So it makes inherent sense that I go a Ca with a +2. Well, if I lose 2 electrons, I become Ca with a Ca with a 0. If I lose 2 electrons, I become Ca with a +2, and then I add the electrons separate because it done lost those electrons. Okay, and notice now there's a +2 electrons on the reactant side. There's a +2 electrons on the product side, so they cancel out. Mg +2 gaining electrons, reactant side, gaining of electrons. If you're a Leo says GER or an oil rig person, that's reduction half reaction. Bottom one, oxidation half reaction. Ca0 is losing 2 electrons, losing product side. Good. We just wrote 2 half reactions based on the reaction that we saw. Theory about what we just did. both half reactions with equal numbers of electrons on both sides so they cancel out. That's what we just did. There was one gained 2 electrons, the other lost 2 electrons. If I drop $2, you ain't picking up one. That number's got to be the same. So you'll see in some of the reactions towards the end, we'll actually have to balance based on those number of electrons gained and lost. And then the reduction half reaction is just the element that's being reduced. Both forms of that metal are shown with the zero and with the charge, reactant and product, with the number of electrons gained on the reactant side. So reduction will always have electrons on the reactant side. Maybe that's how you remember it, because reduction is electrons are going to be on the reactant side. Maybe because those both begin with R. Maybe that's how it works for you in your brain. Oxidation now is the opposite. Again, both forms of the metal are shown, but the number of electrons lost now is on the product side, and that is what we just did in that last example. Okay, good. Now on to the oxidation agents. These are the elements that are being reduced. It's the opposite. They're responsible for the gaining of electrons. They're responsible for gaining the electrons lost, right? They enable oxidation is losing, so the oxidation agent is going to enable that loss, right? So if you lose your electrons, I'm the one that's scooping them up. I'm responsible for you losing yours. I grabbed them. I have a role to play in what happened to you. The opposite's true for the reducing agent. Okay, I'll let you give you a second to write that all down. They are equal and opposite. Okay, and then I think we're going to go to a full-fledged example like what's in your packet, I hope. Yeah, this is what your actual packet looks like. So notice the reaction's written. First thing we have to do is assign our oxidation number. So Mg is going to get a 0, Zn is going to get a 0. You have to live in class in front of the board. I'm going to hunt down the zeros first, are the easiest. So he's a 0, he's a 0. Then I'm going to use ZnCl2 to figure out who Zn is. Off the dome, I think Zn only has the one choice. But if it did have more than one choice, I know Cl is a -1. There's 2 of them. Total negative charge is -2. So the total positive charge has to be +2. So I'm going to use that -1 on both sides. He's a +2. No, he's a +2. Mg's charge is only one charge possible, +2. So there we go. So now I know I have an Mg0 on the reactant side going to an Mg +2 on the product side. Okay, and how did I do that? It must be because I lost 2 electrons. Now notice the reduction and reduction and oxidation half reaction I'm doing in a different order than I did in the previous example. Whichever order you do is fine, but in the way the practice is set up, it's going to ask you to do the oxidation number first. There's probably a reason for that. It's the one who's losing electrons. I'm actually going to probably do the reduction one for you in class first, because it's easy to see which one's going down. From 0 to +2 is going up. That doesn't sound like oxidation or reduction to me. But that Zn +2 going to a Zn0, oh, that number is reducing. It's getting smaller. That's where we get the name reduction from. I'm actually going to probably do the reduction for you live in class. The oxidation half reaction is Mg0. That means the reducing agent then is also Mg0. He's responsible for the reduction. The thing that's being oxidized is responsible for the reduction. Okay, I can already tell you now who the oxidizing agent is, if you kind of figure out the pattern. All right, now Zn +2 is going to go to Zn with a 0 on the product side. Well, what did he gain to get from Zn +2 to Zn0? He must have gained 2 electrons. Notice my 2 electrons cancel out. My Zn +2 is now the oxidizing agent. He is responsible, even though he's being reduced, he's responsible for the oxidation of the Mg. Okay? This is how we do these things. I don't know that's going to be another example, so let's look. There is, probably because we got a balance, but Let's assign the oxidation numbers first, right quick. Lone elements get 0. Cl is a -1 in both cases, so both metals have to go to a +1. No balancing here required. Hg0 on the reactant side goes to Hg +1 on the product side. How many electrons did I lose from 0 to 1? 1 electron. Reducing agent, Hg0. Notice it's the reactant metal. Same thing for oxidizing agents. Can be the reactant metal in the reduction reaction. Ag +1 on the product side is Ag0. What did I gain to get from +1 to 0? I gained 1 electron. My oxidizing agent is Ag +1. Sweet. So these two examples were pretty routine, just like you'd expect. And we do have one. Yay, this one needs to be balanced. So let's do it. Get right into it. Assign our oxidation numbers first. Cu gets a 0. Ag gets a 0 because they're lone metals. AgNO3. Ooh, NO3 is a -1 charge. Polyatomic ion. Both sides. But here's the thing. I only got one AgNO3 on this side, so the silver's got to be a +1. I have two NO3s on this side, so it's a -2, so the Cu's got to be a +2. So this is where I can see right away the zeros match, but the pluses don't match. When the pluses don't match, now we got an issue. And we're going to have different numbers of electrons. We're going to have to balance. It's okay, though. Let's just finish it out. Cu0 goes to Cu +2 on my product side. Notice the arrows still in between those two bad boys. And then how many electrons did I lose? Well, from 0 to 2, I lost 2 electrons. My reducing agent Cu0. Finishing out my Ag half reaction, I got a +1 going to Ag0 on the product side. I gained 1 electron. See, one lost 2, one gained 1. That's a problem. So what we do is we just take this reduction half reaction. We take the whole thing because those two things don't jive. We just take the whole thing, put parentheses around it, and multiply it by 2. So now it's going to be 2 Ag +1s, right? Well, that means I need up on the reactant side, I need a 2 in front of the Ag +1. And I'm going to make it 2 electrons, bang. And I'm going to have to put a 2 in front of this Ag0. And then upstairs, I got to make that happen. I need a 2 in front of the Ag +1, so that's a 2 here. I need a 2 in front of the Ag0, that goes here. And that's it, it's balanced. The coefficients are 1 on the other side, but now my 2 electrons lost equal my 2 electrons gained because I multiplied that half reaction by 2. Beautiful. You could put the 1s in if you'd like I taught you to do in the past, but that is the one complicated example. There should be 1 or 2 of these in your practice packet, and from here on out, from here you should be able to do most of the practice. So do the practice, check your work in class, and moving on to video 5.